mathematicians, and we will continue with our Precalculus course. Today we'll see about modeling and equation solving. The first subtitle will be numerical models. As you can see, you see a table here of employment statistics between the female and male gender. The first question says, according to the numerical model, what has been the trend in females joining the workforce since 1954? The year, you will find it here, and the female trend, you will see it here. And as you can see, the female trend is increasing, except for a slight drop that they had between 1999 and 2004. You can see your answer revealed here. Increasing except for a slight drop between 1999 to 2004. Now let's continue with letter B. Letter B says, in what 5-year interval did the percentage of women who were employed change the most? When did they increase the most? Because we already said that it was increasing. So for letter B, we're going to write it here. Now, as you can see, your female was increasing except for these years. We need to find where is the difference greater. The difference is greater between 1974 and 1975. So your answer here is between the period of 1974 to 1979. With this, we will continue with the next type of exercise. The next type of exercise is algebraic models. It says stepping stones. A garden shop sells 12 inches by 12 inches square stepping stones for the same price as 13-inch round stones. We are seeing a square stepping stone that looks like this and a round stepping stone that has a diameter of 13 inches. If all of the stepping stones are the same thickness, which option gives the most rock for money? Okay, to find which option gives the most rock for money, we need to find the area of each figure. So we will start by finding the area of the square. The area of the square is s to the square is your formula. We substitute, it says that the side is 12, it will be 144 square inches. Then we find the area of the circle, pi r squared, where r is the half of a diameter. That means that the area here is pi times 13 divided by 2. You can write it as a fraction, or you can use your decimal, 6.5. 6.5 to the square. If you evaluate this information, you'll have that the answer is 132.7 square inches. As you can see, the best option was the square stone. Let's continue. Then we have a physics student obtains the following data involving a ball rolling down on an inclined plane, where t is the elapsed time in seconds and y is the distance traveled in inches. So we have the elapsed time here. It says that it's from 0 to 1.2. That means that if we write a function, or if y is equal to, my elapsed time is 1.2. Okay? Then the variable that you're using is t. If I substitute this information, 1.2, but instead of t, I put 0, the answer is 0. It would be correct for this one. 1.2 times 1 is 1.2. Is also correct for this one. 1.2 times 2 now is not 4.8. This will be 2.4. So I need to put a square. And if I do that here, it also works. It will be 4.8. That means that my answer, because it says to find algebraic model, would be 1.2 t to the square power. Let's continue with the next type of exercise. Okay, continuing now with the same table, but now it says to model the data graphically with two scatter plots, one on the same graph, and one showing the percentage of women employed as a function of a time, and the other showing the same as men, for men. Measuring time in years since 1954. We're not going to do them all. We're just going to work until 1974, okay, because of time. Now, women will be in red color, men will be in blue color. It says that from 1954, this is your year, 1959, 64, 69, and 74. And we have 10, 20, 30, 40, 50, 60, 70, 80, and we know that 90 is the one that follows. Okay, so let's do the women part first, the female part. He says that in 1954, females were 32.3. 1954, 32.3 females. In 1959, they increased by 35.1. In 1964, they increased 36.9. In 1969, it increased 41.1. And in 1974, it increased 42.8. That would be the women's scatter plot. Now the men's scatter plot. It says in 1954, 83.5. Then it reduced 82.3. Continue reducing to 80.9. Increased to 81.1. And reduced again to 77.9. And that would be the male scatter plot. Let's continue with the next type of exercise using the same table. It says model the data algebraically with linear equations of the form y is equal to mx plus b. Write one equation for the women's data and another equation for the men's data. And it says that use 1954 and 1999 order pairs to compute the slopes. That means that we're going to use this to compute the slope, and it says 1999 to compute the slope. The formula for the slope is still rise over run. So we will do the female first. And rise over run would be, this is my x value, this is my y value. x1, y1, x2, y2. So the rise over run would be 58.5 minus 32.3. 58.5 minus 32.3 over 1999 minus 1954. If you evaluate this, you can use your calculator to solve this. It will tell you that it's 0.582. That is your slope. And since this is the first year, we're going to deduce that this is my y-intercept. That means that is my b. My equation for female is y is equal to the slope 58.2 x plus 32.3. And this is your equation for your female. Now for male. For the male, let's change our color. The information is actually different because of the y value. So we will have that males is equal to, or the slope is equal to, so we will have that slope is equal to 83.5 minus 74.0. You can do it this way also, over 1954 minus 1999. The answer for the male is 0.211. That means that my equation is y is equal to 0.211 negative x plus the first point that was 83.5. And this is your answer for this type of exercise. Let's continue with the next type of exercise. It says the zero factor property. Solve the equations algebraically. We're going to go back to black color. And what we're going to do here is that we're going to use our FOIL to solve this equation. 2x to the square minus 5x plus 2, we cannot add or subtract because they don't have any like terms. But in this case, this is a multiplication of FOIL. X times x would be x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6. And we copy the plus 3x that we had there. As you can see, you can simplify your 3x with the 3x, indicating that now you will have 2x to the square minus 5x plus 2 is equal to x to the square minus 2x plus 6. We isolate and leave everything equal to 0. 2x to the square minus 5x plus 2. We move all the numbers from the right to the left, changing their signs. we have this here. We continue solving now by adding like terms. 2x to the square minus x to the square is x to the square. We subtract them. Negative 5 plus 2x will be negative 3x. And 2 minus 6 is negative 4, and this is equal to 0. Now we're going to do something that is called factoring. We're going to find two numbers that multiply, give me x to the square, in this case x and x. Two numbers that multiply give me negative 4 would be negative 4 and 1. We cross multiply to check our answer. This will be 1x and this is negative 4x. As you can see, if we subtract this is negative 3x, that is the number that we have in the middle. That means that is correct. We are going to copy x minus 4, equal it to 0, and we're going to copy x plus 1, equaling it to 0 also. We solve for x in both cases, x equals 4. We solve for x in this case, x equals negative 1. And there you have your two answers for this equation. Now, for the next type of equation, we just have to do first our distributive property. So we will have that this is x to the square because x times x, and x times 7 would be 7x. The next step is move the 14 to this side so that you can check if you can factorize. As you can see, we cannot factorize because 14 added or subtracted will never give me a number multiplied 14 and added or subtracted 7. So we're going to use what we know as the quadratic formula. Quadratic formula states that, I'll write it here, x is equal to negative b positive negative square root of b squared minus 4ac, everything over 2 times a. So we just need to substitute. X is equal to a is equal to 1, b is equal to 7, and c is equal to negative 14 as seen here. If we substitute, we will have that is negative 7 positive negative square root of 7 to the square minus 4 times a, that is 1, times c, that is negative 14. If you evaluate all this divided by 2 times 1. If you evaluate, you'll have negative 7 positive negative square root of 7 to the square is 49. And negative 4 times 1 times negative 14 would be positive 56 over 2. You add 49 and 56, x is equal to negative 7 positive negative square root of 105 over 2. We are going to find our decimals, and our similarities will be negative 1.09, and the other one would be, this will be the 1, this will be the 2. The other one is 2.86, adding and subtracting. So let's continue with the next type of exercise. Okay, for the next type of exercise, you still have to isolate for x, in other words, solve for x. So what we're going to do first is that we're going to multiply everything by a square power. That way we eliminate our radical. This is just like saying 3x minus 2 times 3x minus 2 to the square power. And this is like saying 2 to the square power is 4, and you eliminate the square root, you'll have x plus 8. We use distributive here and we use FOIL here. We will have, I'll change the color, we'll have 3x minus 2 times 3x minus 2 is 9x to the square minus 12x plus 4. Already solved. And this is 4x plus 32. The next step is move the 4 and the 32 to this side. 9x squared minus 12x plus 4 minus 4x. Remember that we discussed this already. Minus 32, that we changed their signs. And everything is equal to 0. We check if we have like terms. 9x to the square has no like term. Negative 12x minus 4x would be negative 16x. And 4 minus 32 is negative 28 equals 0. We are going to use now the quadratic formula. X is equal to negative b, so it'll be negative 16 positive negative square root of negative 16 to the square minus 4 times a, that is 9, and c, that is negative 28. All this divides 2 times 9, that is a. If you solve this, you'll have that x is equal to negative times negative is positive 16, positive negative. You can solve all this in your calculator. It will tell you that is 1,264 over 18. You can simplify the 1,264, 16 positive negative, it will be 4 square root of 79 over 18. You simplify all your numbers here, you'll have that your answer is 8 over 9 positive negative 2 square root of 79 over 9. And this would be okay, that would be it for this course. And don't forget, math is magic.